Okay, welcome back everyone. This video is our third video. The numerical method that we are going to learn today. This one is called as a secant method. Okay, secant method is actually very much similar to the false position or regular falsy method that we learned in the last lecture. The formula for calculating the next root is almost similar, but there is a slight improvement where as you remember in the earlier methods, the false position and the bisection method, we needed that the bracket that we chose initially, x0 and x1 or a and b, those had to be such that the value of function when x was equal to a and x was equal to b, or in case of false position fx0 and fx1, they had to be of different signs. Like if fx0 was negative, then fx1 had to be positive, or f of a negative, then f of b had to be positive, right? But in the secant method there is no such condition. Here you can very well have both the fx0 and fx1 negative or both of them positive, and still that's okay. I mean, the root does not need to be between x0 and x1 for this method to work. Okay, so this is not a bracketing method, this is actually called an open method. Okay, so this one is an open method, please make a note of that. Alright, the formula for this, let me give that to you. This is nothing but xn plus 1 is equal to xn minus xn minus 1 divided by f of xn minus f of xn minus 1, the whole thing multiplied by f xn. Okay, so for the first iteration, x2 is going to be x1 minus x0 divided by f of x1 minus f of x0, whole thing multiplied by f of x1. Okay, I think you got that. Alright, so that's the first iteration. For the next iteration, that is x3, you will have to go with let me just write down the second iteration here. x3, that is going to be x2 minus x1 divided by f of x2 minus f of x1, the whole thing multiplied by f of x2. Okay, and so on and so forth till you get the either the number of iterations that you chose, or maybe if they have given it like accurate up to 3 decimals, then until you get the 3 decimals accurate for the 2 consecutive iterations. Okay, so that is what's supposed to happen. Alright, so here one added advantage is that we don't need to keep calculating and deciding what our next bracket is going to be. Okay, so the last method we used to do that. We used to choose one part of the bracket and ignore the other one. Okay, here we don't do that, we just go on calculating it like x2, then take the value of x2, depending on that we go for the value of x3, calculate fx3, then x4, fx4, something like that. Okay, so the reason being that this being an open method, it's not necessary that one of the brackets has to be removed. Okay, so that's an improvement, so which means I think a bit less calculations or less thinking, just going on putting the values again and again. So it's a quick method and a better method, such that we don't have to keep calculating any kind of initial bracket. If you remember, we used to do that in the last class. We had a problem that x cube minus 17x square plus 15x minus 12 is equal to 0. So in that case, I think some of us had to do the calculations starting from 1, and when they reached 16, 17, they got a sign change. So here we don't have to do that. That's an added advantage. Okay, so I think we should start with our first problem. Okay, let's take all right, solve fx is equal to x cube minus 2x minus 5. Okay, okay, correct up to okay. All right, let me tell you one thing. If the equation that is given to you, take a look at this one, x cube minus 2x minus 5. So if the equation is simple enough, like right here we can just see that if we take the f of 1, that is f when x is equal to 1, then this one, the value would be 1 cube minus 2 into 1 minus 5, which is 1 minus 2 minus 5 minus 6. If we take the value of 2, f of 2, then it's going to be 2 cube minus 2 into 2 minus 5, so that is 8 minus 4 minus 5, which is minus 1. And when we take the 3, f of 3, then that's going to be 3 cube minus 2 into 3 minus 5, which is 27 minus 6 minus 5, which is plus 16, right? So a sign change occurs here, and calculating this is easy, right? I mean, it's very easily we can see that the initial bracket, if we wanted an initial bracket, that would be between 2 and 3. So let us write that down. F when x is equal to 2 is equal to minus 1. F when x is equal to 3 is equal to plus 16. Okay, so if we had to choose, then just let's choose this bracket if it's simple enough. Okay, if it's a complex function and getting that iteration is not so easy, then I wouldn't recommend that. Then don't consider this bracket as 2, 3, anything. Just take a random kind of bracket and continue. All right, so here because it's a simple bracket, we'll take this. All right, so here 2, 3, so let's write down x0 is equal to 2, x1 is equal to 3, f of x0 is equal to minus 1, f of x1 is equal to 16 plus 16. Okay, so let's go with the first iteration. x2 is going to be x1 minus x0 divided by fx1 minus fx0 into f of x1. All right, which means that this one is 3 minus 2 divided by 16 minus 1, the whole thing multiplied by 16. Right, that's right, whole thing multiplied by 16. Yes, that's correct. So this is nothing but 3 minus 2 is 1 into 16, so 16 divided by 16 minus plus 1, so 16 minus 16 upon 17, right? So this is nothing but 2.05 0.8823. Okay, we can, as I told you earlier, if the number of decimals is not given, you can just take the 4 or 5 decimals. So here we'll consider is at 2.0588. okay, the 3 decimals are given, so we'll take 4 initially and then at the end we'll just round it up. Okay, I'm sorry, I think this one was out of focus, was it? Just take a look at this. Okay. So that's the calculation for this. Okay, so this is the first iteration of x2. Let's see what f of x2 is. Okay, 2.0588 cube minus 2 into 2.0588 minus 5. Okay, so this one is minus 0.3911. okay, all right, so f of x2, that is negative. That doesn't make a difference though. Okay, so x3, that is going to be equal to x2 minus x1 divided by fx2 minus fx1 multiplied by fx2. Okay, which is, just as we calculated, the x2 is 2.0588 minus 2.0588 minus let me see. Okay, minus 3 divided by the f of 2.0588, that was minus 0.3911 minus 16, and the whole thing multiplied by fx2, which was minus 0.3911. okay, let's see what that is. Okay, 0588 minus 3 divided by minus 0.3911 minus 16. Multiplied by minus 0.3911 2.0588 minus the answer. So the next iteration, x3, is 2.0813. okay, this is x3. Let's find out what fx3 is. Okay, so 2.0813 cube minus 2 into 2.0588 I'm sorry, 0813 minus 5. okay, this is minus 0.1468. alright, okay, let's see. Right, that's right. Okay, now the third iteration, x4 is equal to x3 minus x2 divided by fx3 minus fx2 multiplied by fx3. So this one is equal to 2.0813 minus 2.0813 minus 2.0588 divided by minus 0.1468 minus of minus 0.3911, the whole thing multiplied by f of x3, which is minus 0.1468. okay, let's calculate that one. This one is 2.0813 minus 0.0588, this thing divided by minus 0.1468 minus plus 0.3911. okay, so this thing is, as you can see, 0.0921, this thing multiplied by minus of 0.1468. okay, just the minus thing, so 2.0813 minus answer, that gives you 2.0948. okay, so that's your x4. Now let's see what fx4 is. So it's cube minus 2 into answer minus 5. 0.0030. okay, so fourth iteration, that is x5, that's going to be x4 minus x3 divided by fx4 minus fx3, whole thing multiplied by fx4, okay, which is 2.0948 minus 2.0948 minus 2.0813 divided by 0.0030 minus positive minus 0.1468, whole thing multiplied by 0.0030. okay, alright, let's see what that is. 2.0948 minus 2.0813, okay, the whole thing divided by 0.003 minus plus 0.1468, this thing multiplied by 0.003, okay, 2.0948 minus the answer, just 2.0945. right? Okay, does everyone have that? All right, 2.0948 and 2.0945. If you take a closer look, if we round this off the x4 up to 3 decimal places as per our numerical, so that is 2.095, right, rounding off, and just do this, then this one also becomes 2.095, right? So as we can see, the value of x4 x4 up to 3 digits is 2.095, and the value of x5 up to 3 digits is also 2.095, right, equal. So which means that we have reached the end of our solution, and that solution is the root to 3 decimal places is 2.095. Okay, let's start with the next problem. Here the fx is equal to 3x minus cos x minus 1. Okay, and what we have to do is we have to solve it till 4 iterations. Okay, alright, 3x minus cos x minus 1. Okay, let me just start with maybe taking a kind of a guess at what the initial bracket should be. Okay, if it's 0, then 3x, that's gonna be 0. Cos of 0 minus 1. Okay, what's the cos of 0? That's 1. So minus 1 minus 1, this is going to be minus 2 f of 0. Let's see what will be the 3 minus cos of 1 minus 1. Okay, alright, so I've chosen the initial bracket as 0, 1. Okay, alright, so x0 is equal to 0, x1 is equal to 1, f of x0, that's minus 2, f of 1, that's 1.4597. Okay, alright, so let's start with the first iteration. x2, that will be x1 minus x0 divided by fx1 minus fx0 multiplied by fx1 which is equal to 1 minus 0 divided by 1.4597 minus of minus 2 multiplied by 1.4597. Alright, so this is 1.4597 divided by 1.4597 minus plus 2. Okay, so 1 minus the answer. So 0.5781, that's x2. Now let's see what f of x2 is going to be. Alright, 3 into 0.5781 minus cos of 0.5781 minus 1. Okay, so fx2 is minus 0.1032. Okay, alright, let's see second iteration. x3 will be x2 minus x1 divided by fx2 minus fx1 multiplied by fx2, right? So which is let me see, equal to, oh, I'm sorry, 0.5781 minus 0.5781 minus 1 divided by minus of 0.1032 minus 1.4597. Okay, multiplied by minus of 0.1032. Right, this one is equal to, okay, 0.5781 minus 1 divided by 0.1032 minus 1.4597 multiplied by minus of 0.1032. 0.5781 minus the answer, 0.6060. Okay, that's the next iteration. And f of x3, that will be 3 into 0.60660 minus cos of 0.6060 minus 1. Okay, minus 0.0039. okay, so that's fx3. Let's see what's the third iteration is gonna look like. x4, that will be equal to x3 minus x2 divided by fx3 minus fx2 multiplied by fx3, okay, which is equal to x3, that's 0.6060 minus 0.6060 minus 0.5781 divided by fx3, that's minus 0.0039 minus 0.1032, okay, and multiplied by minus 0.0039, okay, which is equal to 60 minus 0.5781 divided by minus 0.0039 minus plus 0.1032, whole thing multiplied by minus of 0.0039, okay, that's it, and 0.6060 minus the answer, that is 0.6071. that's x4. Let's see what fx4 is going to be like. Okay, so 3 into answer minus cos answer minus 1. Haha. So that's up to 4 digits, it's almost 0, right? Take a look at this one. Okay, 0.6071, that's our answer. So 3 into 0.6071 minus cos of 0.6071 minus 1. Okay, up to 4 digits, that's 0. Amazing, right? If it so happens that an equation, as you can see here, the equation that we had initially was 3x minus cos x minus 1, which is kind of a linear equation. There is no power of x more than 1 in here, so which is why it's very much possible that a root can be gotten to in less than 4 iterations. So there's nothing wrong in that. If you get a value of x that is going to give you the value of x4, say up to 4 significant digits as 0, then it's okay. I mean, you can just take this as the root and just write it down that after 3 iterations, root of the equation up to 4 decimals is 0.6071. okay, just write that down as your answer and you're done. I think that should wrap it up around this about the secant method. This method is not very difficult, very less tedious, less calculations, so doesn't matter, right? That you have multiple iterations or not, more than 5, 6, it's okay if you get the answer in 3 iterations. So just practice it, practice as many problems as you can for this, and you should be alright for the exam. Alright, okay, good luck.